Hello, welcome back to Algebra 2 Notes with Miss Faust. It has been a little while since I've seen some of you between trips and everything else, and you're probably not watching this until right before we come back to school, so you guys have had a lot of time off, but welcome back. Let's jump right into it and do some math. What we're going to look at today is how can I use graphs in algebra to solve a system with a quadratic and a linear equation. So we're looking at putting two things together, how we can then solve a system with either graphs or with algebra. So the first thing just to know is that a quadratic equation, remember, can look like this. Whoops, ax squared plus bx plus c, or it could be in vertex form, x minus h squared plus k. We do know how to graph both of those. If you don't know how to graph both of them, go back and watch the last video again. And a linear equation has the form y equals mx plus b, or something that we can rearrange into that form. So we're going to look at how we can use graphs and equations to solve those. So one thing to keep in mind is that there's three possibilities. You could have 0 solutions, you could have 1 solution, or you could have 2 solutions. And let me just take a minute and show you what that would look like in a couple of different graphs. So here's an example. What you can see here, and don't worry too much about this part, focus on the graph part. What you can see is that I have graphed y equals x minus 2 squared plus 3. So if we look at the vertex of this, it's at 2 and negative 3 because it's the opposite of that negative 2 and then the negative 3, and it opens up. And then the second blue line I've graphed, I've just used some sliders for that linear equation so that I can show you some different examples. So if you look at those right now, you can see right here and right here, those two lines, excuse me, are intersecting in two distinct points. So sometimes when we look at these, we'll get exactly 2 points like that. But what I can do is if I move this line down, still intersecting in 2 points, you can see all of a sudden if I get it in just the right place there, now those are only intersecting in 1 point, just at 2, negative 3. So that's another possibility, is that they just intersect at 1 point, and then you can imagine if I move it a little bit more, now they're intersecting in 0 points. So everything down here, they have no intersections. And the way we're going to see that algebraically is we're going to get imaginary solutions, or we're going to get, we're not going to be able to factor. So if we get imaginary solutions, it means that that linear equation, that linear equation's down here somewhere, and the linear and the quadratic don't intersect. And just to see some other examples, like if we take that right there, now we have 2 solutions again, right? So we can move these around. We can move that up and down. As it moves up, it still has 2 solutions. We just can't see one of them right now. So that could happen when you're drawing graphs because you're not always going to make them giant. But just remember that just because you don't see it, it could still have 2 solutions when you're graphing. The way you'll know, you'll be able to tell pretty easily. For example, if this was like right there when you graphed it, you would be able to tell from looking at that on your graph paper that they only intersect once. Okay, so just use a little common sense and you'll be able to figure that out though. So bringing us back then to the idea of how we solve these. So what we want to do, we're going to look at using graphs first. So the big idea when we're using graphs is that first we have to graph both lines or functions. And remember, if we're looking at a linear equation, we would use the y-intercept and then the slope to graph it. And if we're using a quadratic, if we're in standard form, we're going to have to find the vertex and then build the graph from there. And if we're in vertex form, we'll use the vertex from h and k and then build the table and graph from there. So in our first example, oops, sorry, that got crooked. Did not mean that to get crooked. I think I'll have room to do one here. So example 1, graph both functions, sorry, I forgot the second part. Second part is find the intersection points. And then those points where it intersects, those are going to be your solutions. Now I can do example 1. So example 1 is y equals x squared minus 6x plus 9, and y equals negative 2x plus 9. So what we're going to want to know for these is where those two lines intersect. This one's going to make a parabola, this one's going to make a linear equation. So let me build a little graph over here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I'm going to put this down here only because I know where the solutions are going to be. Kind of get to cheat a little. Let's go ahead and just do the linear function first. So in our linear function, which is this one, I'll graph that one in green. Our slope is -2. Our y-intercept is 9. So I'm going to go to 9 on my y-axis. 2, 4, 6, 8, 9. Let me just double check that. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep. Down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. And I could keep going with that. Connect them with a straight line. There's my linear function. Now for my quadratic, I have to find the vertex first. So the quadratic I'll do in red. So I need to do -b over 2a. This is in standard form, so I need the opposite of -6 over 2 times 1. Opposite of -6 is 6 over 2 is 3. I plug in the 3 to get the y-coordinate. So when I plug in that's my x value. When I plug in 3, I get 3 squared minus 6 times 3 plus 9. Well, 3 squared is 9 minus 18 plus 9 gives me 0. So my vertex is at 3, 0. So I'm going to build my table. I know this isn't very big, but I think you can see it well enough. So I put that 1, 2, 3 and 0 in the middle of my table. Then to build the rest of my table, I count up to 1, 4, 5. And then remember, I only need to make one side of that. So when x is 2, y is 2 squared minus 6 times 2 plus 9. 2 squared is 4. 6 times 2 is 12. 4 minus 12 is -8 plus 9 is 1. It's going to be symmetric, so that's what's going to go there as well. And when x is 1, I don't have room to write it here, but I'll just talk you through it. So 1 squared is 1 minus 6 times 1. 1 minus 6 is -5 plus 9. -5 plus 9 is 4. So I got my points. 1 and 1, 2, 3, 4. 2 and 1. 3 and 0. 4 and 1. 5 and 1, 2, 3, 4. And what I can see then is my graph. It's going to go here, and then it's going to go up from there like so. And what we can suddenly see on this graph, hopefully you can see it, is that those two lines intersect right there and right there. And the coordinates of those points are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And 4, 1. So when we're solving these, we're always getting sets of points like that. Remember, if you had drawn these graphs and they didn't meet, then you have no intersection and you have no solution. So you just write no solution instead of writing those points. If they'd met in one spot, you'd write 1 point. I'm not going to show you more examples of that because I think if you've been practicing graphing, these are going to be pretty easy using graphs. The other way that we can solve them is using algebra. So let me just readjust here. There we go. Da, 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 da. Your questions, my notes. Solving using algebra. And when we solve using algebra, we're using some systems techniques that we learned in Algebra 1, specifically substitution. So what we're always going to do, and you may or may not remember this, but that's okay, that's what I'm here for. When we solve by substitution, we want to make sure we have one equation solve for y. So solve one equation for y is our first step. Then we plug in that expression, whatever we got y equal to, in our second equation. That's the substitute part, so we know what y is equal to, so we substitute or replace y in the second equation. And then we solve that expression, or that equation. And that equation is going to be quadratic. So to solve it, we either use factoring, completing the square, or the quadratic formula. And I'll show you a couple different examples where you can use different methods to solve. Okay, so example 1. Now we're just going to do a lot with numbers. We're not graphing them anymore. We're just looking at what we do if we want to solve them using algebra methods. So whoops, second one. Can't talk and write at the same time. Does that ever happen to you? Okay, there we go. So when you do some substitution, we look at this. We notice this equation's already solved for y. Yay, that's good news. Because this can replace this y in our second equation. So we're going to do the plugging in. That's the substitution step, or the plugging in. So I'm going to write x squared plus 4x equals, instead of writing y now, I write 2x plus 6 plus 3. So I'm replacing that y in the second equation with the 2x plus 6. Just doing it in green so you can see where it comes from. So if we look at this, it's now a complicated looking quadratic equation, but it is something we know how to solve. So I'm going to just simplify it a little bit. 2x plus 9. I'm going to move these over here. X squared plus, whoops, so I subtract 2x and subtract 9, subtract 2x and subtract 9. So 4x minus 2x is 2x. And I get x squared plus 2x minus 9 equals 0. Now since there's nothing in front of the x squared, I'm going to think for a minute, because if I could factor this, that's going to save me some time. When I look at this, I think about things that might multiply to negative 9 and add to 2, and I can't think of any. So I can't do that. I could use completing the square. So to solve this by completing the square, I need to use this middle term. I need to move the 9 to the other side, so I'm going to make it x squared plus 2x equals, when that moves over, it'll be a positive 9. So to figure out what goes here and here, I'm going to do that 2 divided by 2 and get 1. And then I'm going to square 1 and get 1. So I'm going to add 1 on both sides. And then I'm going to factor this into a perfect square. So that's going to be x plus 1. 9 plus 1 is 10. So now I can use square roots. So I will take the square root of both sides. And again, this is good because it's showing you another example of completing the square. I get x plus 1 equals positive or negative square root of 10, which I don't know off the top of my head. So give me one moment, please. I didn't mean for that to be a square root of 10, but life is not always perfect and there are decimals in the real world, so here we are. Square root of 10, 3.16. Not imaginary. If this had been imaginary, this is where we'd have no solution because we'd have imaginary ones, which aren't real. Subtract 1, so I do x equals negative 1 plus 3.16. Or x equals negative 1 minus 3.16. And you can't see that, but I'll fix that. No worries. So negative 1 plus 3.16 is 2.16. Oh, I could have done that. Negative 1 minus 3.16 is negative 4.16. So now, and this is the thing we have to remember, we have the x coordinates of our two solutions. What we don't have yet is the y coordinates. So we're going to use these x values, right? And we're going to take those and we're going to plug them in to find the two y values. Because remember, when we're talking about these, we're talking about coordinates, and points always have an x coordinate and a y coordinate. Now when I do that step of plugging in to find the y values, I'm going to use the linear equation. It's going to be a lot easier to plug a number in here and get y than it is to plug it in here and have to solve for y. So to find my y's, I do y equals 2 times 2.16 plus 6, and I do y equals 2 times negative 4.16 plus 6. And for the first one, I get 10.32. And for the second one, I get negative 2.32. So my two solutions are 2.16 and 10.32. That's 1 point. That's one solution, not two. My second one is negative 4.16 and negative 2.32. So if we were to graph these, we'd see that they do intersect in two places, not right on grid lines, but still somewhere in between, and that gives us the exact values. So that was a way that we could use completing the square to solve that one. At this step right here, if you love the quadratic formula, you could also use the quadratic formula to solve these. Let me show you one more example of this, because I think solving them algebraically just helps to see a little bit more. Notes. Example 2. I don't know why I spelled it out that time. That's okay. You don't really care either way, right? Okay, so my example 2, let's use x squared plus y equals 2x plus 4x, and x plus y equals 1. So when I look at these two, notice neither one of them is solved for y. But if I look at the second equation, it's pretty easy to see that if I subtract x over onto the other side, I will have that solved for y. So again, then I'm going to use that substitution method. I'm going to take this and I'm going to put it where the y was. When I do that, I will get x squared plus 1 minus x equals 2x. This was never supposed to have an x. 2x plus 4. That looks a little better, right? Why wouldn't I have just written 6x? Because there's not supposed to be an x there. Oh, Miss Faust. There she goes again. Okay, so now let's work with this. Move everything to one side. So subtract 2x and subtract 4. I'm going to put the minus 2x under that x because that's what's going to go together. And I get x squared. I'm going to write the x term next, just so it's in a form I'm more familiar with. Negative 1 minus 2 is negative 3x. 1 minus 4 is negative 3. That equals 0. At this point, let me just double check and make sure I don't have a mistake. No, I think I'm good. Think about whether I can multiply two things to negative 3 and add them to negative 3. I don't think I can. So because I don't think I can, I'm also going to notice that this is odd. Since this is an odd number, completing the square is just going to be kind of obnoxious. So I'll solve this with the quadratic formula. And my a is 1, my b is negative 3, and my c is also negative 3. So x is the opposite of negative 3, plus or minus the square root of negative 3 squared minus 4 times 1 times negative 3, all over 2 times 1. So x is 3 plus or minus the square root of 9 plus 12. 4 times 1 times negative 3 is negative 12. The opposite of negative 12 is positive 12, all over 2. So x equals 3 plus or minus the square root of 21 over 2. Again, I get a decimal. I wanted this one to be a whole number, but life's not always that friendly. So x equals 3 plus 4.58 over 2, or x equals 3 minus 4.58 over 2. This one gives me 3.79. Try that. Super common mistake is people put the whole thing in their calculator at once and end up with the wrong number here because this gets divided by 2, but the 3 doesn't. You got to do 3 plus 4.58 first and then divide by 2. Just a warning. Second x is negative 0.79. So again, remember those are my two x values. I still need to find my y values. So I'm going to come up here. I'm writing it again to remind you. Really common mistake with this is people only find the x's and they're like, oh, that's 2 numbers, I'm done. Yeah, it's 2 numbers, but it's not 2 sets of coordinates, which is what we really need to solve these. So I'm going to use this one. This is already solved for y. I can just plug in my x numbers right there. 1 minus 3.79, or y equals 1 minus negative 0.79. So 1 minus 3.79 is negative 2.79. 1 minus negative 0.79 is 1.79. So my two solutions are 3.79, negative 2.79, and negative 0.79, 1.79. Okay, and again, these can be solved graphically or algebraically. When you get decimals like this, it's actually easier, unless you have a graphing calculator, it's a lot easier to see them when you solve them algebraically. But I'm just going to take a minute now and show you how we could verify that using graphs. So let me just get rid of these guys and we'll verify our answers. So we're going to type in x squared plus y equals 2x plus 4, and x plus y equals 1. Okay, let me just change the color of one of those so you can see a little bit better. There we go. You can zoom in. We had zoomed out before. And as we zoom in, we see one of the solutions right here is at like negative 1 something. Oh no, not 1 something. This is negative 1. Yep. So if I zoom out, there we go. Yeah, not quite negative 1 and not quite negative 2. That's our solution that's at negative 0.791 and 1.791. The other solution is down here at 3.791 and negative 2.791. So the graphing calculator is a useful tool for this. I show you that because when you get to smarter balance testing, you will have this exact graphing calculator to use. So if you're solving a problem, you always can use it to find the solution to 2 equations, to a system like this. Okay, I think that's it for today. I will stop making the little arrow bounce around the screen and I will sign off and say have a wonderful afternoon. I'll see you soon. Ciao.